Okay, so on hyperbolas, we've got the x squared and the y squared, but there's a minus between them. In this case, it's x squared over a squared minus y squared over b squared equals 1. And that, we talked about it, that's right and left branches because the x squared is first. We got the y squared minus the x squared over here. And since the y squared is first with the minus, that's a right, upper and lower branch hyperbola. So here's the way we're going to do it. Basically the same way we did with the ellipse, but different. X squared over a squared. All right, so I'm going to go out x, we're going to go a and negative a, the square root of that, and then the y, I'm going to go b and negative b on it. But for hyperbola, I don't connect those elliptically, right? It's hyperbola. So what I do with those is make this called the fundamental rectangle. Draw in that rectangle through the a's and the b's. And what those give me are the asymptotes. Draw the diagonals, extended diagonals through that. And then since it's right and left branch, it hits this one and this one, that'll be my vertices. And then it'll be asymptotic, I believe that's a word, to those asymptotes I drew in, both sides. That's how I get my branches. It's not that bad. Just have to do a little rectangle and then diagonals. And, yeah. Same thing over here, except it's upper and lower branches. Here I go, now be careful, y squared over a squared, this one's the y, so I'd go a here, negative a here, and then the b, I mean, it could be, just depends on the numbers, which one's bigger. Could get a longer one like that, but then drawing that rectangle. They draw those diagonals. This one has upper and lower branches, and so they go upper and lower instead of right and left. This will be your vertex here. This will be your vertex down here. So that's how you get hyperbolas. Now, the foci, the equation there, well, c squared, the distance to the focus, is a squared plus b squared. So you might notice the foci equation runs opposite of the sign between your x squared and your y squared, right? Because on the ellipse, it's plus here and it's minus there. On the hyperbola, it's minus here, plus there. So anyway, it's the same basic equation so you have. And again, the foci will be in here for those, and then here and here. Like I said, it's a little more complicated than the others, but not too bad. All right, so let's try try a couple.
Does it matter where F1 and F2 is as far as top bottom?
As far as numbering them, no.
No, okay.
Just whichever you feel you want to be one, which one do you want to be two.
Okay.
I don't think they usually make that distinction.
All right.
Because usually write them together, because it's usually plus or minus. Well,
Yeah.
on these that are not shifted. But anyway, all right. Okay, so x squared over 9 minus y squared over 16 equals 1. So yeah, that's a hyperbola. The x squared is first, so it's right and left. So how far on the x do we go? Square root of 9, 3. So on the x we go 3 minus 3. The y's do the square root of 16, 4 and negative 4. But you draw a rectangle with those. Straight up through those, straight over from those. Fundamental rectangle. That gives you the diagonals extended, gives you the asymptotes. Slant asymptotes. Which way do I draw the branches? Right and left. Right and left, okay. So it's asymptote here, vertex here, asymptote, vertex, asymptote. How do you do it? Like I said, these are the vertices, vertex 1 and vertex 2 would be plus or minus 3, 0. And just real quick here, the foci, c squared equals a squared plus b squared, so that would be c squared equals 9 plus 16. Oh, that's going to work out. That's c squared equals 25, so c would be plus or minus the square root of 25, which is 5. Again, you want to go out, the foci are outside of the vertices, one way to look at it, different ways. But so here's the focus points here, -5 and +5. Okay? Plus or minus 5, 0. All right, y squared over 49 minus x squared over 25 equals 1. Also a hyperbola, but the y squared's first, and so that would be upper and lower, right? Up, down branches? And again, these are, be sure, we get used to putting the 49 as the x, but that's the y, isn't it? Because it's under y squared. So I go out in the y, plus or minus 7. And then under the x, plus or minus 5. Okay? Draw in the asymptotes then. That's what I like you to see. Drawing these. But since it's upper and lower branched, up here and down here instead of over here and here, right? It's y squared first. That's how I know that. And then the foci, c squared equals a squared plus b squared, so that would be c squared equals 49 plus 25. That would be c squared equals 74, so that would be c equals plus or minus the square root of 74, which is about
8.6.
6. Well, again, the foci are located, oh, I didn't say the vertices. The vertices are right here at this plus or minus 7, 0 plus or minus 7. The foci are outside of those vertices, so I'd go up to 8.6 and down to 8.6 down here. One more just little mention here, just again to, I'm pretty sure that get it set up anyway. What is that one? Last one. X squared minus 16, y squared equals 64.
You
What
divide
should?
it all by 64 to get
It's a hyperbola, isn't it? Because I've got x squared minus y squared, that's a hyperbola, but it's not in that form. Again, it needs to be 1. So divide everything by 64. And we got it, don't we? That would be y squared over 4. All right. So now I know, yeah, that's a hyperbola. X is first, so that's right and left branches. Do my thing, rectangle all the time. So go from there.